to do, but Professor Kuck has come from Utah to speak with us today. He's educated in Germany. I think he grew up most of his life in Germany and then worked with Draeger for a long time. His role with Draeger was Director of Bioengineering, and worked alongside clinicians to understand application of technologies on the shop floor of anesthesia and intensive care. So he's got some background in what he's doing. He's been widely published. I mean, I'm not going to list any of those papers. There's lots of stuff out there. And he holds a screen full of patents as well. So he's got a lot of experience in this, but I'm personally very pleased to realize he rates the collaboration between technology and clinicians is highly important, and I think it is very essential that we embrace that side of our practice for delivering best practice care for our patients and optimal health care. So SCATA does enjoy links with other societies, and I think we've heard that already. Professor Kuck is president of the American version of the Society of Technology and Anesthesia, and he's here today to talk to us about big data and its relevance to anesthesia. Thank you, Professor Kuck.
Thank you. Thank you so much for the nice introduction. And also for the kind invitation. I think it's great that our two societies can work together like this. And we had guest speakers at our last meeting and hopefully at our next. And I think it's really great to do this transatlantic collaboration. So I'd like to talk to you guys about big data, and I've seen in the program tomorrow there's quite a bit of data focus there, so take this as a teaser, a little appetizer. I want to do three things. I want to kind of remind ourselves how big data is defined. I want to show where big data is used outside of anesthesia, because there are some really fascinating use cases. And then focus on anesthesia and see how we're doing and what the outlook is. So big data is really a buzzword, right? It's maybe dying down now that it's big data and blockchains. It's one of those buzzwords where everybody heard about it, but we're not quite sure what it is. And Gartner defined it in 2001, in the early 2000s, having the three V's. So it's volume, the scale of data, velocity, and variety. And then later, a fourth one came in, and it was veracity. So let's take a look at that. Volume really refers to how much data you have to store. And many of these things, so volume and also velocity, of course, they have to do something with our current technology. I would imagine 100 years ago, 10 megabyte was big data, right? Because you couldn't store it very well. 90% of today's data has been created in just the last 2 years. Fascinating. We're creating 2.5 quintillion, I don't even know how many zeros that has, bytes of data every day. And so it's this volume, and of course, as computer technology advances and storage technologies, these numbers will go up, and what volume is can be redefined. Similar to velocity, and there really the key is it enough data? Is it so much data that I have to do real-time analysis to do something with it, to keep up with it? I can't just, keep storing it for a month and then analyze it. I have to analyze it in real time. Variety, right? So we're creating videos and music and text and other things, images, and that all contributes to the variety of data. And then most of that, of course, is unstructured. Just imagine physicians' notes, right? How do you interpret them? How do you deal with those notes? And then veracity, I'll get more into that when we later talk about the anesthesiology part of it. 1 in 3 business leaders don't trust the information they use to make decisions. Haven't been in industry, I wonder how many really use data to make decisions. 3.1 trillion is estimated, that's the amount of money lost to poor data. So those 4 V's, and lately there's a 5th V now. We shouldn't just do big data because of big data. We should do it because, and only for those cases, prioritizing that, which actually creates value. So big data is really used in lots of different places. And I'm just going to go into a few of those, and I do that, and I want us to keep in mind, wow, if they can do that, imagine what we can do in anesthesia with this stuff. So, for example, in sports, those of you who watch US basketball, every of these NBA arenas have these 6 cameras installed above them, and the cameras can very closely track 25 times a second where every player is, where the ball is, who is in possession of the ball, what is the speed of each player in the ball, and what are the distances between these. And then, of course, once you do that, and they do it in real time, then of course you can come up with statistics, right? So top right here, probably Leonard has the ball, and then you can calculate, well, what are the probabilities where the ball is going to go? What are the probabilities if he does pass the ball to Matt Bonner? What are the probabilities that he's going to go for a successful shot? So you can do a lot of statistics on this. Retail, of course, is what everybody's interacting with, and that's where the big money is. And 3/4 of retailers, brick-and-mortar stores, are using government publicly available data. Almost 80% are using GPS and mobile data, and almost 2/3 are using Facebook and Twitter feeds. And they do that to reach their customer, to understand their behavior, and then, of course, at the end, to boost their sales. And as far as understanding behavior, it's just an example. In the US, we have this big department store chain, Target, and they were in the news, and what they have done is they're actually creating a guest ID where they look at your email click-throughs, they look at what kind of online coupons are you using, they know where you live and how far away are you from the nearest store, what you're purchasing, what you're looking at, what is in your wedding registry, and what are on these other lists. And then they create the guest ID and pull it all together. And they were in the news with the New York Times a few years ago because they showed with their predictive model, they look at 25 selected products of the purchasing behavior of customers, they can predict the pregnancy due date to within a very, very small range, very small window. So, and then of course they can target what they advertise to you and all these other things. Here's another example which I find fascinating. So Amazon, they have a patent, they filed that in 2013, where they say, we know our customers so well, we're going to start shipping products towards them before they even press the purchase button, right? So they start, they're not going to send it to you, but they start and putting it towards, the distribution center in your town, and they feel so confident about it, they have a patent, and I don't know whether they're instituting it already, but they feel they can increase customer satisfaction more with that. Another area, of course, is mobile technologies. Nokia, when they were still a thing, they had every 2 years, I believe, they had these challenges. And a group, Domenico, Lima, and Mussolesi, in 2012, they won it. Then they looked at the address book contents of the phone, the GPS tracks, the Wi-Fi and the Bluetooth traces, and then the calls and the text logs. And what they were doing, they were able to predict where these phone users will be in 24 hours. And they could do that within 20 minutes. Fascinating. This was in 2012, and now, of course, those of you who have iPhones, I get these messages even though there's nothing in my calendar or anything. The iPhone should know where I'm going, but it tells me how the traffic is and how long I may need to get there. Social marketing. We are interacting a lot with Twitter and with Facebook, and we have Google searches, and every 60 seconds we're producing enormous amounts of data. And all of that feeds into what the marketeers call the typical customer purchase journey, right? So there's TV ads, there may be a billboard that they're seeing, there may be display ads, and a lot of this stuff is accessible electronically. And all of these things then lead to a decision to buy or not to buy. And this is just to show you, all these logos are companies that are serving different pieces of these customer journeys and the data collection and the data aggregation. And every single one of these using very complicated algorithms and rules and flowcharts. And here's just one example. This is a flowchart of the software that Google is using to to determine which ad they should show you, right? So you can see this is very complex, and it seems to be working. So the yellow bars here, they show Google's ad revenue over the last couple of years, and the gray bars are newspaper ad revenues. So they do something right. It's also true for this whole social marketing is also true even closer to home, where we at the Society for Technology and Anesthesia, we have talked to many of our industrial sponsors, and they are now shifting some of their marketing dollars away from supporting societies. They're still supporting us, but they've dropped many others, more towards more social media and interacting with customers in that way. They find it to be more profitable. Another area, of course, is politics. And all of us have seen these maps where, you know, who is in the Democratic and who is in the Republican camp. But this can actually be done with a lot more resolution. There's this company called Political, and they're able to break it down into much higher resolution. So this is a similar map in the United States. You can see it's more purple than red or blue. And they get even closer, and they can break it down almost to the household level. They have all that data. This is all from publicly available sources. And then in their software, you can now, if you're running an election campaign, you can click on the people you want to target. Who do you want to canvass? Who do you want to call? Who do you want to email? And then get very detailed and very focused campaigning to them. And of course, now you can take these publicly available data and you can combine it with Facebook and all these social media things. So big data is used in amazing ways in all these other areas. How about anesthesiology? And I'm not an anesthesiologist, but I'm very impressed by what you guys are all doing. And this is a drawing from David Gaba in his Crisis Resource Management book, where he's showing, and I'm not going to go into the details, where he's showing how complex it is, what you guys are all doing, where you provide leadership, you need to use the resources well, you need to communicate, you need to monitor and cross-check, you need to allocate your attention, you attend to data streams and prioritize and schedule your actions, and then you need to observe, you need to recognize problems, you have pre-compiled responses, and so to me this is very, very complex. And if you don't do this right, the patient will get hurt. Very complex, as we heard, can be very stressful. And it's shameful to me as somebody who has spent his career in medical device and anesthesiology technology development, that in order to support you with all this complex stuff, this is what we do. And this has not changed in the last, I don't know how many years. My predecessor, my PhD supervisor, Joanne Westensco, he had a talk where he actually showed it. I'm not sure how true this is, but it's kind of neat to think about it. It seems even the order of this seems to be not making any sense, rather than, you know, the historical perspective, which one was developed first, right? The EKG first, and then the blood pressure and the pulse oximeter. And yes, I know occasionally there are some numbers on the side, right, entitled CO2 or heart rate, but it's basically raw waveforms. And they're displayed as if they don't have anything to do with each other than they're collected at the same time. And then from the left side here, you look at the electronic medical record screens. They're probably even worse, right? Because their usability factors are really, really bad, and some of this stuff is automatically collected. A lot of this stuff needs to be entered, and it's very difficult to make use of. I think we can do a lot better than this. With that, we are at a level of the physiological variable. This is the level of clinical observations and therapeutic interventions. So this is really the data level, right? And we need to aggregate that, and we need to extract information out of that to get to the next level. And by that, I mean you enrich it with context information, you prioritize and target the specific situation, and you need to visualize it in meaningful ways. The next level up would then be to add knowledge to it, right? To find similar cases or common practice or best practice, or what are the potential risks? What is a real-time estimation of outcome? Could you predictively detect patient deterioration? As a company in Oxford Biosign here out of the UK has done successfully in patients on the hospital ward. Can you help with optimizing resource allocation? Much of this stuff can be automated. Much of that stuff, and I hope we hear about that tomorrow a little bit more, much of that stuff can be done by computers and machines, and probably better than humans can do it. Now, would that be done to replace anesthesiologists or physicians? And I'd argue no, but it would free you up to do what we cannot automate, and that's the application of wisdom, of, you know, the art of medicine. So let's look at, let's do a little deep dive on the data part. And we earlier talked about the 4 V's. Let's look at how that would look for anesthesia. So if you, and this is from Levin and Wanderer, who published this a few years ago in ANA, if you look at how much data is being produced, so we have, if you just look at the heart rate, high resolution EHR heart rate, it's about 1.8 kilobytes per case. It's not that much. If you take the next level, maybe a 5-lead ECG, and collect the waveforms, now we're talking 37 megabytes per case. If you take all the variables that are captured in an EHR every minute, you're probably looking at about 1 megabyte. And then you multiply it with I think it's like 40 million or some US surgeries per year. So we're talking about 51 terabyte per year, where in other areas, retail, our mobile devices, we talk about high volume, we're talking about terabytes of new data every day. So on the volume side, in anesthesia, we're probably not quite there yet to be big data. More data is coming though, right? So if we start collecting waveform data, if we start to collect images, different story. All of a sudden that volume may reach that space. And here's another interesting thought. So if you look at the genomic analysis costs, they have 2007 or 8, that was probably when some of the gene sequencing algorithms came out, they have actually accelerated beyond Moore's law now. So which means that the prices are going down faster than what the computers can do better every year. And that means sooner or later, when we start seeing genomic data in our EHRs, that's when we're probably going to end up going into the big data piece of the bone part. How about velocity then? So obviously we are generating high-speed data, all those waveforms. We've seen videos earlier, but most of that is not captured today, right? Most of that, if your hospital does have an electronic health record, most of that is captured maybe only once per minute, and images and videos typically not even. And so you don't really need the real-time analysis, and it's not done really, but if at all, it's done maybe on a next day reporting scale. So on the velocity side, probably not there yet either. Variety, we sure have variety, right? We have continuous data, we have numerical data, we have discrete, we have images, we have video. Many data types, actually there's mixtures, right? Think about medications, right? So we have concentration, we have the name of the medication, we may have a generic name, lots of different data types, variety of data sources, all the different devices you have in the OR, and the data comes from all across the system. And then veracity. We don't capture everything, it's incomplete. There's a huge sampling bias with our data right now because it's largely academic hospitals, at least in the US, that are very good in capturing that. But academic hospitals only cover a fraction of the patient population and probably not an unbiased sample. There's measurement errors, and then there's artifacts. And here's a study that was recently done, I think it was in February of this year, where they took 136 pediatric cases, captured all the data, about 10,000 minutes, and then they had observer anesthesiologists and an attending actually determine whether the reading was, for every minute, was an artifact or not. telling whether the value was deviating from normal or not. And you can see that, for example, on the invasive blood pressure, we had almost 40% of those values that were deviating from normal. Almost 40% of those were actually artifacts. And maybe even more concerning, even the normal value, so to a large degree, we're actually having a high artifact incidence. So we're not quite there yet with big data in anesthesia, but we're getting there. And even so, even if it's not big data, it's still sometimes very hard to process. Here's a list of different registries that are actually collecting data. And Richard Dutton, he was the AQI Institute director. He said, silent revolution is underway in anesthesia, one that will have a lasting impact on our patients and our practice. And what he meant by that was the collection of data. And we are part, I just want to highlight that a little bit, we are part of this multi-center perioperative outcomes group. This is an organization, a consortium of more than 50 hospitals, most of them in the US, one in Holland, and I know that there are 2 hospitals in Germany who are trying to get on there as well. And what we're doing, we're also part of that in Utah. What they're doing there is we're basically submitting all of our cases, de-identified with all of our highly granular intraoperative data to MPOC at the University of Michigan. And then it's kind of a shared data resource. So if we then want to do research on that data, they have a standardized database format. We have access to those over 8 million cases. And that, of course, is very rich data to do research. And we have just been awarded the MPOC Enhanced Observational Study, which was a lot of fun because we actually expanded on that electronic data collection, where we said, what if we have this intraoperative data collection, and what if we enhance that with preoperative and postoperative manually collected data? And what if then our participating centers would donate some of their time to do this manual data collection? So we decided to do this, and what we decided to do was look at postoperative pain profiles. Wanted to basically find out what are some of the risk factors in getting transitioning patients who are opioid naive, maybe, to people who are excessively or prolonged opioid users. We were able to work together with 12 university systems. They were all donating their time to collect data. And what we did is we took the intraoperative vital signs and the interventions that are automatically collected by MPOC, and then we added things like pre-op interviews about their home medications, about how bad their pain is, and what their expectation is for the surgery and the pain, some psychometric data on their depression and catastrophizing thinking, sleep disturbance, with thoughts about the symptoms. And then we would de-identify this and send it to the University of Michigan, to the MPOC Center. And we were using a digital case report form they developed, and this is now also available for mobile. It's HIPAA requirement, HIPAA compliant. HIPAA is the privacy regulation in the US. And it's automatically linking this data to the MPOC case ID without revealing the identity of the patient. And then we were able to enroll about 1,130 patients in a very short period of a little bit over 2 weeks, 2 to 3 weeks. So rapid deployment of these surveys. And after we had enrolled them and did the data collection, we then had follow-up interviews at 1 month and then at 3 months. And I can't tell you any results, unfortunately, because we're still analyzing it. We are going to look at those risk factors for post-discharge pain profiles and opioid consumption patterns. But this is just an example of how you can enhance the big data, the large databases that are electronically collected. So moving on from data to information, this is what I always tell my students. This is the future of anesthesia. And Many of you will recognize that picture, of course. It's one of the first publicly recorded cases of anesthesia. Dr. Morton is here on the left with one of the first anesthesia machines in his hands, and they were operating this patient. I say this is the future of anesthesia because Dr. Morton had an assistant, a monitor, who was keeping a finger on the pulse and had some rudimentary vital data that was looking at the patient. And this was an intelligent patient monitor. He knew about medicine. He was context aware. He knew when to interrupt and not, and he could even maybe apply therapies. But we're far from it. We're displaying raw data these days. And I'm wondering, you know, if the airline industry, this is in 2012, 6 years ago, if the airline industry can provide displays like this, where the airline pilot knows whether to go around thunderstorms or mountains, can we do something like this? And maybe the aviation industry is a good example, where on the left is an older cockpit where you see all these different dials that are just displayed next to each other with no relationship other than they're in the same physical location. And the right one is a more modern cockpit where all these data are brought into context, right? And you have artificial horizons, the different pressure, volume, and velocity. Velocity data are displayed, and this display can change depending on whether the pilot is trying to fly the plane in maintenance over the Atlantic, or whether they try to land and they need different information. And some of you may remember this is the early 1990s, the Omida Modulus CD. That was the anesthesia machine, one of the first anesthesia machines with the built-in PC, and they tried that, right? They tried to make a display where they put things into context, but it never really flew. It never really took off, and it's very hard to see displays like this these days. There's been a bunch of studies done, George Blyke and others. They put together to me, a very engineering type display where they try to put things into context. And for example, on the top there you see the x-axis is heart rate, and the y-axis is stroke volume, and then the multiplication, the area of that, of course, is cardiac output. And then they have similar things going with the other variables. Here's another example. This was done in Utah back in the 90s and published in the early 2000s by Jim Agutta and Dwayne Westonsko and others, where they showed, again, they tried to visualize, you know, for example, the ischemia of the myocard, right? So as the ST segment gets worse and worse, it's displayed differently, and you can see the different pressures. This is, by the way, also a nice example of how you could show these advanced displays and show a progression in time. Again, it has not taken off. We hardly see these kind of advanced displays. What we do see, you know, these are some of the products actually that are out there. On the left is the Massimo Radical. They're kind of trying to play around with different display ideas. The middle one is this is Edwards Life Science, where this is almost like the flag display, but just a little bit differently visualized. And on the right side also, this is from Litco, a British company, where they actually define a target range or target area where you should be with cardiac output and hemodynamic data. And then this is where you are, and then there's some indications of what you need to do to go back into a good field. So we do see some displays that are getting there, but it's very hard to move away from these raw waveforms that are shown. Here's an interesting one that took electronic health record device data. And this is the University of Michigan startup Alert Watch, and they even got FDA approval for that, where they basically display now the electronic health record in more meaningful, as they hope, more meaningful ways. And I don't particularly like the way they visualize it, but I do think give them credit for a good effort to put things into context, and they build it out too. You can click on more info or emergency references, and then PDFs open up with maybe with your hospital policies. They have some active alerts, and they also in their system, in order to get this, of course, they needed to integrate all these different values, and so they built the system out so that now you actually have the opportunity to see each one of those boxes here is one of the operating rooms, to be actually almost like a dashboard or a flight control system. You can see how the different operating rooms are doing, and so then you can decide where to intervene. A study by Sachin Catapal and others, so Sachin is the one who invented centricity back then, who has become an anesthesiologist since and is now running the MPOC consortium. And they used this alert watch and figured out whether it made any difference, and it turned out it didn't. It couldn't detect any difference yet, but still, I think it's a good first step on how to visualize data. Moving from information more towards knowledge, here's a study that was done by the MPOC consortium. And what they did there is they found reference values for non-invasive blood pressure in children during anesthesia. They found, depending on age, these nomograms, where kids' blood pressures normally are. And so they found some interesting results. This is based on 116,000 cases from over 10 centers. And then they found computations. And this now can be used, of course, if you enter the age of the patient, you can then automatically set the alarm limits. Here's another alarm limit type study, also from MPOC, where they looked at over 600,000 procedures to figure out, can we make an alarm system to detect infusion rates that are accidentally set too high. So they found for the different anesthetics and vasoactive agents, what are the percentile ranges concomitant with the interportal ranges of the different infusion rates. Here's another possibility, and this is just a concept idea. What if we take from the anesthesia machine the data and add to it all the labs and EHR data and medications, and put it into the record for this hospital, create a database, add to it data from other hospitals that do offline training, and then that trained neural network or whatever learning system, machine learning system you use, put that back to use, and then interpret the data that's coming in, and then you can maybe have some guidance for therapy settings, you can show similar practice, alarm settings, documentation, and maybe you can show like a green, yellow, and red area where you should be, for example, with your ventilation settings or decision support. So this is kind of the pyramid of data, information, knowledge, and wisdom, and then the question a little bit is where things are headed. If you look at other industries, the steps that they have to go through to get to some preventive analytics or big data, actionable big data. And on the y-axis here, you have the complexity, on the x-axis, the business value. So they started with just basic monitoring. What's happening now? Reporting what happened last week. Why did this happen? They compare what happened last week or what happens now to what is average. And then, of course, they move on to prediction, what may happen. And you can imagine how this plays out in the retail world, for example. And then preventive analytics. And if you kind of look at the timeline, so we're talking about, this all started probably around the 1990s with the advent of the internet and the more powerful computers. This was published in 2015, so they reached there, and we can discuss later maybe where we are in anesthesia, but I would think we're probably here. We're probably about 18 years behind the curve. And so the cool thing is that's shameful from a technology development perspective, like myself, on the one hand. On the other hand, it's neat because we can see where the future is going, right? We can see what will happen, and we can find topics. Yeah, thank you very much for your attention.
Thanks, Professor, for that. Very